This is question 81 in chapter 6. It says, consider the system shown in figure 6.81. The rope and pulley have negligible mass and the pulley is frictionless. Initially, the 6 kilogram block is moving downward and the 8 kilogram block is moving to the right, both with a speed of 0.9 meters per second. The blocks come to rest after moving 2 meters. Use the work energy theorem to calculate the coefficient of kinetic friction between the 8 kilogram block and the tabletop. So here is our figure. So it's initially this is moving down, that's moving this way, and eventually it comes to a stop after 2 meters. So we will first start with work equals change in kinetic energy, which can then be written as work equals K2 minus K1, which equals 1/2 mass. So it's mass of the whole system, so it's mass of both blocks. I'm just going to write M, but I mean both blocks. Mass times velocity squared. And this would be our final, let's see, this is our initial, that's our final velocity. So V final, and then minus, so K2, V final, mass times, that will be 0 eventually. It's 1/2 mass times initial velocity, which is your 0.9 squared. And then you can take the 1/2 m's out, just 1/2 mass times velocity final minus velocity initial squared. Well, squared, that's incorrect. It's squared both of them. See, now we can plug in our values to get our change in kinetic energy. So it's 1/2 times the mass, which is 6 plus 8, 1/2 times 14, times 0 minus 0.9. And that equals our change in kinetic energy, which is, when you calculate it out, negative 5.67 joules. Our next equation will be work equals the coefficient of friction times mass 2 times gravity times distance subtracted from, or added to, mass 1 times gravity times our distance. See, what we can do to this equation to make it a little bit easier is, because work equals our delta K, we can put delta K in here. And now, because we have values for delta K, our mass, gravity, distance, mass, gravity, distance, we can solve for our coefficient of friction and then input our values. So let's see, delta K so our coefficient of friction will be equal to delta K minus M1 gravity S divided by M2 gravity S, which is our distance. So here we plug in 8 kilograms for mass 1. For mass 2, sorry. So 8 kilograms for mass 2 times 9.8 times 2 And we're going to have our delta K, which we just found, which is negative 5.67. Subtract mass 1, which is 6, and then again our 9.8 and 2. And when you plug all those numbers in and run it through your calculator, it comes to 0.786. And that is your coefficient of friction in the system. That was question 81 in chapter 6.